Hi guys, unfortunately my SDP isn't working, so I got these pictures of Anas. Thank you so much Anas for these. So I will explain them for the people who need it. So first of all, which of the following must be true for HJGF to be an isosceles trapezoid? Isosceles trapezoid means that this side and this side have to be parallel and congruent, okay? So that means FH has to be congruent to JG, okay? This is one of the options. Another thing is that the base angles have to be equal. So angle F has to be equal to angle J, and angle H has to be equal to angle G. So here we have F equal to J. So these are our two answers for question number 1. Question number 2. Which of the following conditions by itself is enough to guarantee that a quadrilateral is a parallelogram? That's not a parallelogram, my bad. This is a parallelogram. No, it's not even, sorry. I can't draw it, 1 second. Oh my goodness. So, this is a parallelogram. Which of the following is enough to guarantee that it is a parallelogram? So, both pairs of opposite sides are pairs of parallel sides. That means this side and this side are parallel, and this side and this side are parallel. This is true. Both pairs of opposite sides are pairs of congruent sides. This side and this side are equal. This side and this side are equal. That is also true. Its diagonals are perpendicular? No. This is the case only in a rhombus. So in a rhombus like this, no, that's a triangle, sorry. In a rhombus like this, the diagonals are perpendicular. One pair of opposite sides are parallel and congruent. So if this is the parallelogram, this is the parallelogram. One pair of opposite sides are parallel and congruent. We said yes, they are parallel and they have to be congruent as well. So this is correct. But if they only told you one pair of opposite sides are parallel, this is not enough. It's not enough to prove that it is a parallelogram. So this is it for question number 2. Now for question number 3. Which of the following conditions by itself is enough to guarantee that a quadrilateral is a parallelogram as well? Let's draw a parallelogram. Both pairs of opposite angles are pairs of congruent angles. So this and this are congruent, and this and this are congruent. That is correct. One pair of opposite angles are congruent. So if this and this are congruent, but these are not, it's not gonna be a parallelogram because both pairs need to be congruent. Now, each pair of consecutive angles are supplementary. That means here, this is 180. This plus this 180. This plus this 180. This plus this 180. This plus this 180. So yes, this is correct. One pair of consecutive angles are congruent? No, the pairs of consecutive angles cannot be congruent. This could only be in a square or a rectangle. Two of its angles are right. They're only right if they are in a rectangle. So that is number 3, done. So which of the following conditions by itself is enough to guarantee that a parallelogram is a rectangle? So let's say this is a rectangle, okay? We know in a rectangle that the diagonals are congruent. This is one thing. And at least one of the angles have to be right. So if one of its angles are right, then that's correct. If they tell you 1 or 2 or 3 or 4 instead of here, then it's still correct. So these are for the question number 4. So for question number 5, solve negative 6x plus 9 greater than or equal to 39. Negative 6x plus 9 greater than or equal to 39. Bring the 9 here. Negative 6x greater than or equal to 30. Negative x greater than or equal to 5. Now, we got in the end negative x greater than or equal to 5. Anytime we're dealing with a negative next to the variable, okay, and we're gonna be dividing by the negative number, so by -1, we're gonna have to flip this. So negative x divided by -1 is x. We're gonna flip this, it's gonna become less than or equal to, and 5 divided by -1 is -5. Now, to which direction is the arrow pointing? It is pointing towards the left side. That means this is our answer. Why? Because there's also an equal. If there is an equal, that means the circle is full. And whenever they ask for b, it is usually the number that is next to x, or the number that we found that corresponds to the x. In this case, it's -5. So that's number 5 done. So now we need to solve question number 6. Solve the radical equation. Radical 4x minus 15 plus 5 is equal to x. Anytime we have something like this, we should leave the radical by itself on one side. So we're gonna move the 5 to this side. Radical 4x minus 15 is equal to x minus 5. Okay, now we square both sides. Why do we square both sides? To get rid of the radical. So we're gonna have 4x minus 15 is equal to x squared minus 10x plus 25. Okay, now we bring the 4x and minus 15 to the other side. We're gonna have 0 is equal to x squared minus 10x minus 4x plus 25 plus 15, and then in simplest form it is gonna become x squared minus 14x plus 40 is equal to 0. So this is our answer. Now our answer was this. We need to factor this. How do we factor this? By doing the product sum, and after doing it, you're gonna get x minus 4, x minus 10 equal to 0. Then when we are gonna find the roots, we're gonna do x minus 4 is equal to 0, so x is equal to 4. X minus 10 is equal to 0, so x is equal to 10. And now we have to substitute to see which one is the correct answer. So if you put 4 here in this equation, you're gonna get radical 4 times 4 minus 15 plus 5 is equal to 4. Let us check. Radical 4 times 4, 16. So radical 16 minus 15. Radical 1 plus 5, is it equal to 4? 1 plus 5, is it equal to 4? No, so it is wrong. How about if we tried 10? It will be radical 4 times 10 minus 15 plus 5 is equal to x. So radical 25 plus 5 here, sorry, is 10. Radical 25 plus 5 is equal to 10. 5 plus 5, is it equal to 10? Yes, so then our answer is 10. That was for question number 6. Now question number 7. Given that G is the centroid of ABC, MG is equal to 10x and AG is equal to 28 plus 6x. Just by looking, AG, it is way bigger than MG. So that means half of AG is equal to MG, or double MG is equal to AG. So if MG is 10x and AG is 28 plus 6x, okay? And we said that double of MG is equal to 28 plus 6x. So 20x is equal to 28 plus 6x. Bring 6x here. Now we have 14x is equal to 28. So then x is equal to 2. And that's how we solve it. This one is one of the easiest questions, to be fair. So we're gonna have x is equal to y minus 2 and y is equal to 18. We just substitute. X is equal to 18 minus 2, so then x is equal to 16. Very simple. Next question. Question number 9. In the diagram below, M and K, okay, we have MS is 35 and L is 25 XR is 14 and they need us to find YF. So we do, since M and K is similar to XYZ, we do 35 over 25 is equal to 14 over YF. Now we do cross multiplication, or first we simplify this. We're gonna have 7 over 5. The 5 doesn't fit here, sorry. We're gonna have 7 over 5 is equal to 14 over YF. Now how does 7 become 14? We multiply it by 2, so 5 will become YF. If we multiply it by 2, that means YF is 10. Done. Okay, now in a case like this, when we have tangent or sine or cosine, here is a trick. So, thank you for the teacher for teaching me this. So it will stand for sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tan or tangent is opposite over adjacent. So here they need the tangent of y. First let's find all the sides. So we use Pythagorean theorem. We do a squared plus b squared equals c squared. We have c and we have a, we only need to find b. So we substitute. 2 squared is 4. 4 plus b squared is equal to 104. B squared is equal to 100, so b is equal to 10. If this is 10 and they need the tangent of y, we said tangent is opposite over adjacent. We take the opposite of y, which is 10, to the adjacent, which is 2. So 10 over 2, which is 5. That's it. Now for question number 11, we have a circle with center O, and then we have 2 chords, and we have lines that are perpendicular to the chords that pass through the center. If they are perpendicular to the chords and they pass through the center, what does that mean? That means they are perpendicular bisectors. So if they're asking for the value of MS, this one, and we have the value of FM, it's 28, and we know that OS is perpendicular to FM, that means we can find the value of MS. So the meaning of perpendicular bisector, that MS is equal to FM over 2. Okay? So MS is equal to 28 over 2, so it's equal to 14. That's it. So based on the circle, you have to find out first it's a perpendicular bisector. Then if you are sure it's a perpendicular bisector, then you can use this method. Now question number 12. We need to subtract px from qx, but here qx is positive, so that means we need to change the sign of every single monomial, or the whole polynomial. We need to change its sign. So first we start by putting px. We have 5x to the power of 4. We're gonna put it in standard form, where we go by decreasing exponent number. So first 4, then 3, then 2, then 1, then none. So 5x to the power of 4 plus 4x to the power of 2 plus 12x to the power of 3 minus 6x plus 9. Now we said we're going to change all the signs of this one. So for 25x to the power of 3, we put it under the 12x to the power of 3, and we change the sign. 2x to the power of 4, we change the sign and we put it under 5x to the power of 4. 4x, we change the sign and we put it under 6x. And negative x squared, we put it under 4x squared and we change the sign. Now we add 9 stays 9, minus 10x, minus 13x to the power of 3, 5x to the power of 2, and 3x to the power of 4. As you see, it's not in standard form. When you do it in standard form, it's gonna turn out like this. 3x to the power of 4 minus 13x to the power of 3 plus 5x to the power of 2 minus 10x plus 9. Okay, so for question 13, it's not that obvious, but I think this is a plus. So anyways, we're gonna take out the common factor. It's gonna be negative 2y. Why is it negative? Because the first digit is negative. So negative 2y minus 6x squared y divided by negative 2y. It is 3x squared. 10xy squared divided by negative 2y. It's minus 5xy. And 4y to the power of 3 divided by minus 2y is negative 2y to the power of 2. Then if we're doing product sum, we're gonna have negative 6 is the product and negative 5 is the sum. So what could be the only possible values? Negative 6 times 1 and negative 6 plus 1. Okay? So now we're gonna substitute. How do we do that? We're gonna take 3x squared, and instead of minus 5xy, we're gonna do minus 6xy plus 1xy minus 2y squared. And now we're gonna factor even more. So what's the common between these? It is 3x. 3x squared divided by 3x is x minus 2y. Here, what's the common? Y. So xy divided by y is x and minus 2y. That means our final answer is 3x plus y and x minus 2y. But don't forget outside we have negative 2y. This is our final answer. Love you till the day that I die. Amanda, you're gonna have to cut that out. Okay, so here we're gonna do question number 14. We have something like this. What I personally like to do, I like to take the denominators out first. We have 4y, y minus 1, and 6y squared. Now let us find the least common denominator. Between 4 and 6, the LCM is 12. Now which is bigger, y or y squared? Definitely y squared. And which is more, to not have y minus 1 or to have y minus 1? To have. So this is our LCD, 12y squared times y minus 1. Now 12y squared times y minus 1. Now, how did 4y become 12y squared times y minus 1? How did, this become 12y squared times y minus 1? We multiplied it by 3y. That means we also have to multiply the numerator by 3y. Plus, how does this one become into 12y squared times y minus 1? We multiplied it by 2 times y minus 1. So that means we have to multiply 5 by 2 times y minus 1. After solving, the numerator is going to turn out 3y squared plus 3y plus 10y minus 10. And solving it even more, you're going to get 3y squared plus 13y minus 10. And this is exactly what they're looking for over here, 13. So our answer is 13. Okay, so now for question number 15. We need to solve a rational equation. Whenever we have something like this, first we need to expand the numerator. We're gonna make it into the simplest form it can be. So it's gonna be 2x times x minus 9 over x is equal to 0. Now see, can we cancel anything in numerator and denominator? Yes. Now we're left with 2 times x minus 9. Now we make each part equal to 0. So 2 is equal to 0 and x. So we're gonna have to make each separate part equal to 0. So 2 is equal to 0 and x minus 9 is equal to 0. Now which makes more sense? 2 to be equal to 0 or x minus 9 to be equal to 0? Definitely the x minus 9 to be equal to 0. This makes 0 sense. And then we're gonna get x is equal to 9. Done. Now question number 16. We have 16 over 81 to the power of 3 over 4. Check the denominator. It is 4. That means we have to make 16 and 81 something to the power of 4. 16 is 2 to the power of 4 and 81 is 3 to the power of 4. So if we put it to the power of 3 over 4, that means we're doing 4 times 3 over 4. 4 times 3 over 4 is 3. So that means for both of them, the exponent is gonna be 3. So 2 to the power of 3 over 3 to the power of 3. So it's gonna be 8 over 27. Now question number 17. This is very easy. Okay, we need to expand this. So we're gonna do it. We're gonna square this. It's gonna become 4x to the power of 2. Then we're gonna do 2 times 3 times 2x. So that is 12x. And then we're gonna square 3. We're gonna get 9. That's our final answer. Now the final question, which is question number 18. We're gonna do it now. Now, first of all, we check, is there any common? No. So we're gonna do the product sum method. What is the two numbers? You multiply them, they give you negative 120, but you add them, they give you negative 7. You're gonna get negative 15 and 8. Now, we only have to substitute it in the middle. So 6x squared minus 15x, okay, plus 8x minus 20. So we're gonna here take out the common, which is 3x. It doesn't fit. We're gonna take out the common, which is 3x, okay, and we're gonna leave behind 2x minus 5, okay, and here we're gonna take out the common, which is 4, and we're gonna leave behind 2x minus 5. So that means our final answer is 3x plus 4, 2x minus 5. Done.